Happy birthday to us. Happy birthday to us. Happy birthday to my Ether friends. Happy birthday. You're 10.
Woo! Nice. Thanks, Justin. Happy birthday, Ethereum. So officially kicking off the second decade of Ethereum with AllCoreDevs. So bunch of things on the agenda today, mostly some Fusaka clarifications, uh, and then talking through the rollout of the upgrade, and then we can continue the discussion around Glamsterdam headliners. But yes, to kick us off, uh, Harry or Barnabas, do either of you want to give an update on the Fusaka devnets?
Yeah, sure. I can get started. So, Fusaka DevNet tree has been mostly stable. We have two CLs that are a bit struggling, Lodestar and Nimbus. So they seem to have different bugs. Lodestar is having a library P2P bug that they are debugging in the past few days or few weeks. Maybe someone from Lodestar team can give us an update if anyone is here. Otherwise, uh, Nimbus had a MEV related bug that should be fixed now, and yeah, participation is up to 94%, so should be good to go. We're going to be doing some perfect peer testing in the coming days, and hopefully that will also work for all the CLs.
Thank you. Any client team or anyone else want to add anything to the devnets? Okay, if not, then there were two issues that came up this week that we should discuss. The first is very much an EL issue, which has to do with the which has to do with the transaction size capping. So Duncan brought this up on Ethereum Magicians, saying that if we cap at 16.8 million gas, it would cause some problems for some of the applications, and highlighted a couple of them on the thread. I don't know if he's on the call today. Um, Otherwise, I saw that Tony and Vitalik had responded to this. So if Duncan is not here, maybe Tony or Vitalik can give an update.
Yes, I can do so. Yeah, I think it's fair to acknowledge that.
Sorry. I want to say
Like-
Duncan is on his way.
Okay.
I gave him the link. He was just having trouble finding the link. But yeah, he's on his way.
Okay.
Yeah, I think
guess,
backwards
let's start with
compatibility
Tony
is
and-
super important. I think backwards compatibility is super important, but we had like a lot of discussions around exactly this topic. It feels like the 30 million were just a problem for many different edge cases, like the Xen contract or a lot of attack vectors that's just dependent on using everything for one purpose, and especially thinking of parallelization, we just get nothing from it. And then there were also concerns from CKVMs around 30 million. So these were the reasons why this was lowered, and it seemed like a good trade-off between getting some more scalability, some more security, without really affecting many users.
Okay, thanks. I see Duncan is here. Duncan, do you want to give more context on the actual issue, and then we can go to Ben?
Yeah, thanks. Sorry about that. I had a trouble finding the video link.
Good.
Yeah. The bottom line is that decreasing the transaction gas limit from 30 million to 16.8 million is a breaking change for application developers. And Yeah, it's causing a lot of complexity in our application. I'm sure there are other ecosystem-wide impacts. It's frustrating that this change appears so late-breaking. I like to think that I do keep reasonably well appraised of the ACDE process. And so, having this change be 3 weeks out does not grow my confidence that a thorough ecosystem impact review was performed.
Thanks. Ben?
I mean, I'm sympathetic to the issue, but one of the examples that uses, given that uses over 16 million, and it probably uses more now, was deployed in 2021 when the block limit was 12 million. So it would have been possible, and it's sort of like a complete loop around every single attached contract to a pool. So essentially that would, taken to its extreme, that would need a transaction of infinite gas based on how it's written, because people could keep adding pools to the contract. One of the issues is supporting these larger transactions reduces the overall gas that can be offered to the network. So there's like a balance there. So if you want to do more transactions, then overall and have higher block gas, then we need to reduce how much any individual transaction can do.
Yeah, I could just elaborate a bit on some of the arguments I gave on magicians. Basically, I think one is that we have had a history of situations where we historically have not followed a rule that if X is a breaking change, then X cannot be done, right? And there have been things in the past that we have done, like for example, some of the gas limit increases are one, and then some of the removal of self-destruct is another one, and I think that one's pretty instructive because there's no case that it was security critical. That one was a very significant gain in client development simplicity, but if we had wanted to, we could have done without it. And I think the reason why we want to do these things is because if we don't, then effectively we're suffering a permanent penalty in order to avoid a one-time switching cost, right? And generally, the thing with invariants is that the more invariants you can have, the more they often have positive benefits to simplicity or to security or opening up new client design choices that often we did not even realize, right? And so with the self-destruct removal, for example, we gave ourselves an extra invariant that bounded the number of storage slots that can change in a simple block, and that allowed a bunch of things to actually of things in client development and caching to become quite a bit simpler, right? So I would argue that also the kinds of breaks that are here, they will happen in the context of things that we want to do in the future, like multi-dimensional gas, per code chunk gas pricing, very serious repricings of precompiles. And so I do think that we need a procedure for being able to do things like this. Right. I think is it a breaking change or not? I mean, from the arguments that I've right, the question is also the way that we've looked at these things historically is breaking for how many users, right? And what level of inconvenience, right? Because if there's an application that has no natural path for rewriting itself, that's one thing. But if on the other hand, we're just talking about, like, for example, MEV, like bot activity. Like, I'm personally, totally fine making changes that force MEV bots to rewrite their code, right? So it's like that's one of the balances. I mean, I do think we should be more thoughtful to having a procedure for this. I mean, I am like perfectly happy delaying things like this. I'm also happy to like having time delays and explicit deprecations is I think something that's good. Having explicitly like specified invariants is good. Having and you'd really continuing to like have lists of things that we keep in mind as we change gas prices or is good. So right, wouldn't 30 million per transaction be enough? I think the one use case that I would worry about there is distributed proving, right? Because like basically a distributed prover is going to be constrained by like basically like the way that it parallelizes is it parallelizes across different participants, right? And the way ZK AVMs work is that like basically all of them, they parallelize between transactions. They don't parallelize within transactions because parallelizing within transactions is like 10 times harder, right? And so we that like the value is basically that the more we can, like right now, probably we're not going to be in a position even with like a 10x improvement in prover time to be able to say, well, let's have a distributed prover that would actually be able to handle a worst case block, which involves a single prover keyword transaction that's across 30 million gas, right? Yes, and even when non-distributed, these kinds of things are an issue, right? So I think in terms, right, also parallelizable execution, I mentioned that, right? So just like in terms of worst case mitigations, there's a huge number of these like weird edge cases that exist within transaction boundaries that just don't exist at all between transaction boundaries, because between transaction boundaries, like basically all of the state gets flushed. I mean, except for obviously the state tree itself. So that's kind of how I would argue the case for doing things like this in principle. I mean, I definitely don't have a strong opinion personally about timing, and like I'm actually like I think it's reasonable to be conservative on timing for things that break things.
Thank you. There were a couple comments in the chat. I don't know if anyone wants to speak up about them.
Yeah, I was asked to explain the use case. Yeah, so to be clear, I'm not arguing for no limit. I think having a limit is a really, really good idea, especially in as much as it means it unlocks scalability, parallelism, and also constrains the design space for dApp developers and makes it easier to reason about the system. Really, all I'm arguing is that the limit of 16.8 million is too low. Specifically, my use case, I can't speak to the, what was it, 100 and something million gas that the contract I linked to consumes today. But I can talk about the transactions that I develop, which on chains with, I suppose I should back up and say I represent 0x, a DEX aggregator. So we're building ERC20 swaps that will touch a whole bunch of different pools to achieve best price. And when gas is cheap and liquidity is highly fragmented, as we see on many EVM L2s, 16.8 million, you can blow past that in a $100, $1,000 swap fairly easily. And if we scale L1 and bring execution costs down on L1, we would likely see similar gas consumption for low notional swaps. And so the problem is that the so the problem of optimal DEX aggregation routing under a low gas limit is NP hard, which we've developed approximations for and can solve this problem in production, but it significantly increases the problem, and I think is one of the reasons why you don't see a thriving competitive DEX aggregation ecosystem on chains like Solana, because that constraint is so low and the problem is so difficult. So for reasons of competitiveness, I think increasing the limit to the historical block gas limit of 30 million is a very good idea.
Thanks. Let's do Ben and then Tony.
How much is the gas on the aggregation from storage versus calculations? So would, for instance, repricing non-storage opcodes down, which is planned, help resolve that?
Most of the time, and this depends very heavily on a lot of specifics, but most of the time you are storage limited. Exceptions would be things like Pendle finance, curve finance, really anything that has to do Newton Raphson approximation of a constant function. The reason why you couldn't do 2 transactions is atomicity. Slippage checking has to be performed at the end of a swap, and so you need to be able to roll back the entire swap from the moment the user's tokens are moved in order to achieve that atomicity and avoid some really bad impacts of MEV. And so, again, with Solana making the comparison, not being able to achieve that atomicity in protocol causes people to seek out of protocol solutions, which are typically centralized because you're making a promise for multi-transaction atomicity that you can only guarantee based on some sort of handshake agreement rather than, actual crypto economic security.
And Tony?
Yeah, I think the concerns here are totally valid, and I want to stress that I definitely acknowledge them, and also I hope you had that feeling during the magician's replies. But I think in the end it's just a trade-off, and we have to take a decision on where we put that point. Now we are at 45 million, so 30 million, we can be like, okay, hopefully there was no use case in the meantime that needs those additional 50 million gas. I think that's a fair assumption. But I still think going to 60 million, which is currently the default on the DevNets, is the better choice, just because we get those additional benefits from parallelization. And of course, we affect slightly more users, but this is exactly the trade-off here. We will always affect some users, but other users will benefit from us being able to scale. And yeah, so totally valid, but I still think we should stick to the limit that we have.
Yeah, I guess defining the actual limit is maybe part of the question. Is we originally had 30 set because it was, I think, the gas limit when the EIP was drafted, and obviously the gas limit's gone up since then. And then it got lowered to 16.8 or something. But is there a number? If we did it to 20, or is there some number today that we feel would actually allow most, large use cases that have been used in productions that are somewhat reasonable, and would still allow us to bound it?
So just from the numbers, we know that around, I did a 6-month analysis and a 3 years analysis, and it's around 0.038, so 0.04% of the transactions that were affected. And it's even lower for the users because it's mostly people that use certain contracts. So I think the vast majority of them was Xen. So different accounts using the Xen contracts. This accounted for like the majority of it. I don't remember how much, but I think like 30, 40, 50%. And then there were a lot of batch use cases, like batch ENS registrations, batch payouts, and all that kind of stuff that
Do you
was
have a
already
link to this?
batched. Yes, I have a link. I will post it into the ACDE Discord right now because I'm on a different device than my Mac. Let me check. Yeah. Okay, I posted it right now.
Okay, thank you. I'll cross-post it in the chat here just for people referencing. Oh, thanks, Josh. Yeah, and I guess, yeah, so there's a trade-off here. One approach you could take is, we set a relatively high limit with the expectation it might go down in the future. The problem is then as soon as we set the limits, people will rely on it for something. So there's a risk that if we say, hey, we do 30 million in this fork and we want to take it down in the next fork, like by the time the next fork happens, by the time the next fork happens, we can't lower it. But yeah, we could also commit to saying like we put a hard limit today at 30 million, and then we deprecate these transaction costs some amount on the next fork, and it gives time for people to migrate. And I guess on the 0x use case, like what would happen if this cap existed today and someone was trying to do a transaction that touched a bunch of routes? Is it just that the transaction would fail? Would the 0x, I assume the UI or the front end is able to catch it in the wallet to some way that what would as a user, like what would the experience be if like you tried to exceed this limit today?
Well, so today it's a non-issue for 0x because we've developed the technique for handling this and producing optimal routes under the limit. And it's actually probably better for us because it cements our position in the ecosystem. What I'm saying is that the problem is if you want there to be more competition in the solver, searcher, aggregator ecosystem, then you are raising the minimum level of technical skill required in order to produce valid routes by requiring that they also solve for the transaction gas limit. Because right now, the problem is largely limited by profitability due to the relatively higher gas prices on L1 compared to L2. And so the transaction gas limit is very rarely a problem.
Right.
And if a potential DEX aggregator were to produce a route that's above the limit, the front end would catch it immediately because you can't, you obviously can't submit a transaction with that high of a limit.
Got it, thanks. And I guess, is there a future where we would imagine going even below the 16 million? Because I maybe don't have an intuition for what's the lowest we would actually consider. If is that 16 million, or is that, is there an argument to say it should be 10 million or 8 million?
I mean,
Yeah.
at 16 million for like 45 million gas, you're looking at 3 transactions that can be run in parallel. And then, when we go to 100 million, it's a lot more. And we're specifying that you need 8 cores run a validator. So essentially saying, well, you can't use it. It's entirely single-threaded is, wasteful. Because we have the capacity to increase using parallelism, but setting the limit higher causes the worst case to get worse. But setting the limit lower in the situation where the block gas is getting higher, I don't think necessarily gains much.
Vitalik, you were going to say something?
Yeah, I mean, I've like thought about this and even talked to some DeFi people, and like there is a case to be made that a kind of theoretically spherical cal better Ethereum would be if you push the transaction gas cap all the way down, potentially to low millions, but with some specific carve outs for contract creation. Obviously, but like the reality is that the benefits of doing that are low. So like one exit. And like basically in all of the cases where there are benefits of doing that, you could do specific stuff like say only low gas transactions are eligible for fossil, or only low gas transactions are eligible for some account abstraction feature or something similar. So it's like the balance is basically getting like how much you would get in terms of some of these nice properties in terms of like client side parallelizability and dealing with quadratic attacks and so on. I mean, like what this brings to mind, right, is back in 2016 when we had our most serious DOS attacks. We pushed the gas limit all the way down 500K, and that actually like let the chain run while those bugs were unresolved. But it's like once you go lower, the like benefits do keep accruing, but the returns start marginally start decreasing quite a bit, and also the costs start increasing quite a bit, right? So like once you go into below single digit millions, then I think Starks start becoming impossible, and then potentially they're like just the number of people that have to rewrite keeps going up. So I personally would don't feel a strong need to start pushing into like lower single digit millions or anything like that. And like I, I feel like oh, there we go. That's a good chart from Tony there that just shows how the portion of stuff that breaks is like basically exponential.
Thanks. And Dano, yeah, thanks for putting the charts as well, Tony. And then Dano said that, if we remove the contract size limits, then the transaction gas limit also becomes, in a way, the contract size limit. My proposal to move this forward would be to consider having the limit be 20 million instead of 16. It seems like it addresses some of the cases that were raised. I also think 20 million is maybe a nice number because the gas limit is 36 million now. We expect, or sorry, 45 million. We expect to probably go to 60-ish around Fusaka. And so 20 million gives us the ability to actually run, in the worst case, 2 transactions, 3 transactions in parallel, if we're doing parallel execution. Whereas if we're at 30, it's like until we raise the gas limit to 60 million, there's still cases where maybe we're not able to parallelize. So I don't, that would be my rough proposal. And this 16 million number was basically just a power of 2. So if 20 is slightly better, I think we could make that change. And
yeah, I think it just moves us into one direction of the trade-off. We should be aware of that.
Yeah, and I think the feedback we've gotten is we're a bit too far in the other direction. But yeah, Duncan.
Yeah. I just put out a call to some of our data guys at 0x to do some analysis for like gas consumption by notional trade size on low gas L2s. So I can also provide you guys some hard numbers specifically for DEX aggregation on the impact of this EIP. But that'll be later today.
Yeah, perfect. And would you mind like also finding some transaction hashes, I think, like specifically of some of these like massively multi-atomic arbitrage things?
Yeah, we're not
Yeah,
in the business
yep.
of arbitrage, but yeah,
Right, right,
I'll
I
give
know.
them
Yeah.
studies.
Oh, sure. Okay.
Okay, and so I guess there's two things you can do. Either we like soft agree to go to $20 million gas now, and if we find something that disproves that being a good number, we change it again, or do we prefer to wait a week or two to make the final call? This kind of ties into the fork deployment cycle. Like, if we need to write some tests and update the clients, I imagine this is fairly simple, but yeah, the clients have a preference between coming to a decision now and potentially reversing that, or waiting a week or two, and yeah, having it be more final. Mario?
Yeah, I would like for us to make the least amount of changes possible because it has not been easy to go through all the static legacy tests and finding out which ones break because of these
Okay.
transaction gas limits. It's been extremely hard, to put it like softly. And so the least amount of changes that we do to transaction gas limit cap, the better in the testing
And
team's opinion.
And right now the testing team is assuming we're doing 16.8, not 30,
Exactly.
right?
Exactly. 60 million is the one that we
Okay.
have.
Then in that case, let's leave it at that for now. Get the numbers, and if we are to change it, we make that decision on the next call 2 weeks from now. And this gives us 2 weeks. And if we were to change it in 2 weeks, Mario, like how big of a change would it be then? Like once you've identified all these tests, is it easy to go back and,
Yeah, so the
rewrite it?
approach is that we have to analyze what exactly the test is doing, to be able to not break it and still like provide test coverage for these legacy tests. We have the procedure now. We had not done this before, so we now have the procedure. It should be easier, but I still would like lean towards changing it less frequently as possible,
Okay.
in my opinion.
So less frequently and later is better for you than more frequently and sooner.
That's correct. Yeah.
Okay. So in that case, okay, let's leave it as is now. Make a final call in 2 weeks, if we are to change it. And yeah, this gives us some time to discuss it and yeah, look into the details in the edge cases. So if anything else on this? Just see if we can make the final call on Monday instead of 2 weeks from now. I don't know how quickly we can get the numbers and look through them.
I can probably have numbers at least for 0x by tomorrow morning.
Okay, so let's try. Okay, if you have that, let's discuss it again on Monday's testing call. And yeah, if we feel like we have all the information to make a decision, then great. And at the very least, if it's leaning towards we think we're going to change it, then we'll know on Monday that we need to set up a new DevNet, and we can also figure out the exact right value. Yeah. Okay. Anything else on this? Okay. Well, thanks everyone. Thanks Duncan for raising this and coming on. Okay, next up is another spec issue. This one is more of a CL one. Oh, it's actually just a CL one about PureDAS. It's come up in this thread that basically the increased requirements on CL nodes can affect some of these community staking module like Lido and Rocket will have. And I know that this is the EL call, but it's a pretty significant change. So I wanted to leave some room for people to discuss it today. And at the very latest, it feels like we should resolve this on next week's CL call. So if there's anything we can move forward today on this topic, it would be good. I don't know if either Dimitri, who raised the issue, or anyone who's engaged on the PR is on the call, or?
Yeah, I'm here. Thank you, Tim. So the quick context about the thing and why we are discussing that, in PeerDAS, there is a constant that determines how many samples of this new blob samples, which is 128 right now, CL node is obligated to custody depending on the number or the ETH amount attached to the validators to the node. So there is a feeling that the current number, which is 128 or 4,096 ETH attached to the node being the top requirement for the node to be a super node, might have possibly a negative effect on home stakers, specifically home stakers in the fractional staking protocols like Rocket Pool or Lido CSM or Stater or whatever else protocol, where people only provide a fraction of the capital to custody a full 32 ETH validator, or in the future maybe OXO2 validators as well. So the proposal from my side, from Lido side, from CSM side, is to increase this limit from 4 times from the current value, so that the obligation to be a super node and to custody all of the segments will appear once there are 512 validators attached to the node, or 16,000 ETH. I personally think that this wouldn't make a significant change regarding professional operators and large nodes that we already have in the network, because from my experience negotiating with the professional operators, almost all of them have at least 500 validators, min balance validators attached to the node right now. So it means that their nodes would still be mandatory super nodes, while it will make a curve less steep and would ensure that both storage and bandwidth requirements would not go crazy high for home stakers like myself, for example, who are running validators from home using a very common hardware like DApp node, for example, and who are limited by a household internet connection, which might be not super perfect. And given that the requirement would result in not just storing or custody more segments, but also downloading them in a limited 4-second period. I believe that this limit can be raised, especially given the initial rationale behind selecting the initial value, which was, first of all, compiled, I believe, either a year or year and a half ago, when fractional staking was not such a big thing. And the second is that I believe the rationale was just 1 segment per validator. Maybe it is not a very robust thing, and there is a chance that we can increase the value so that we will allow home stakers to still maintain relatively low requirements both to their hardware and to their bandwidth.
Thank you. See, Ansgar has his hand up.
Yeah, I just wanted to say that I would argue for we should just be very aware that this is not primarily a technical question, but more kind of philosophical question of sorts. I personally am pretty strongly opposed to this change, because I think in principle, what we're trying to achieve is trying to basically have as few economies of scale as possible in staking, right? Because those always push against solo stakers. I understand this specific concern is not about solo stakers, but that's kind of the point, right? Because in principle, staking 32 ETH and staking 64 ETH already should basically be twice the effort, because you also get twice the payoff, right? So of course you need twice the capital, but ideally you should also run basically 2 nodes in 2 locations with twice the bandwidth and twice the everything. In practice, of course, we can't actually fully get there. but that is actively bad. And so like the more we are leaning into economies of scale, the more we are making life harder for solo stakers, especially now that like the staking ratio is increasing more and more, and the kind of the yield comes down quite a bit, and so the margins get slimmer and slimmer. So I personally think at least we should be very, very careful with this kind of change. And if you look at numbers, right, like so for people that actually fully stake their own ETH, we're basically talking about this change like from you could already like you could now stake, I don't know, up to $4 million of capital before you'd even start having to like custody more than the very minimum of columns. I personally think that's excessive. I understand that this is specifically to enable like these use cases where you have like a very high multiplier between your own capital and the underlying capital, but in that case, there's just a lot of fees that should then just go into making sure you can actually still do that. I am sympathetic to this in the sense that I think we should look at least into solutions like someone like that being able to just run nodes in multiple locations that then communicate with each other to basically like so that no one location just has to custody all the columns or something like this. So I do think we should try to facilitate this, but I personally think that the easing the requirements and leaning more into economies of scale is the wrong approach. But I do think people can have different opinions here.
I'm not quite sure that the proposed change is leaning towards the economies of scale. Maybe like is either my misunderstanding of how protocol works or my bad English, but I'm not quite sure that we are talking here about leaning towards economies of scale. I believe we are talking more here about how many nodes would be affected by that, and raising the limit, like anything in between one validator and 500 validator can barely be considered an economy of scale. And again, as I mentioned, from my experience with professional operators, like all of them, they're trying to maximize what they are earning. So they're trying to minimize hardware costs, and that's why they all already run more than 500 validators. And the question is, how much do we affect those running not like a 500 validators, but say, I don't know, 50 validators, for example, in CSM or in Lidos Simple DVT or just in DVT clusters. So imagine you have 7 home stakers who are now building a cluster of 7 nodes. It means that they will need to have each 7 times less capital, but they will all have to run the same number of validators just because of the fact how DVT technology works. And in this case, if they're, say, running to, I don't know, 30 validators or 40 validators altogether, the steeper the curve would be, the more they will be affected. And from my personal experience, right now, like any change that makes it harder to become home staker, makes it less profitable, less convenient, less comfortable, is essentially net negative, because even with the current conditions that Ethereum has to offer, that protocols on top of Ethereum has to offer, it is still extremely hard to get like additional 100 operators on Ethereum network. So for me personally, there is a chance to make a curve less steep so that we will still be able to allow for like a semi-professional node operators to be not, or like large home stakers, let's call them this way, not to get affected that much by this change.
Yeah, Paulus?
I want to mention that there is an actual technical side to this. I want you guys to go and look into that thread on Discord on RNG. Francesco, for example, brought up that it might be beneficial to have a distribution of nodes where we have more nodes that custody the minimal number of columns, and then this bimodal distribution in which we have these nodes, and then suddenly we have nodes that are super nodes that have everything. These nodes, like, they do different kind of things for P2P. The super nodes allow to like reconstruct the blob and serve the other nodes. And having a bunch of nodes in the middle ground might be detrimental because it increases the number of subnets and it just degrades blob propagation. So it might be worth, just from that perspective, to increase the number of validators that you run, while still keeping the minimal number of columns. According to numbers, I mean, of course, this would affect depending on what sort of like the leverage that the staking pool mechanism allows. I believe with Rocket Pool, I think Nixo just pointed that this would be like 4 million or something like this. With CSM, the numbers, as far as I can see from the PR, you would need about 36 ETH, not more than this, to hit this this limit in which you start having more columns to keep. So I think that's not so large of a number. I think we do have home stakers that do stake for about 36 ETH. I mean, many of them would actually like split their own validator and try to take many keys from a protocol like Lido because they just earn more. And I think we do want to incentivize this kind of staking because this kind of staking is what's taking out stakers from institutions. So I don't think that this is something dramatic. I think in that PR, many client devs supported it. And it seems to me that research also supports it, and it seems that it's not dangerous. It might actually even help on P2P propagation. So I don't see why to be opposed to this.
Thanks. Alex?
Yeah, so I think there is this general conversation to have, and yeah, you know, having another look at how this custody works and how it scales, you know, that seems to make sense given all the above arguments. There's a separate question though of like, when is the right time to do this? I think given where we are in the Fusaka R&D process, also a key fact here is we don't expect to like scale the blob significantly immediately after Fusaka. I think we'll have time to get to a place where this would even start to be an issue. So I'd propose we kind of table this change for now, keep looking into it, and you know, as we need to do something about it down the line, we can pretty easily.
And you mean table this change from Fusaka completely?
Right.
Like.
Yeah. Yeah.
How do people feel about this? Yeah, you know, we can make a final decision on this on Monday as well. Like, I think it's important that we at least discuss it now and people have time to review. But yeah, I'm fine making the decision on Monday or at the latest on the CL call next week. Right. Yeah, let's try to. I guess actually, yeah. Is it better to do this on the CL call or on Monday? Like, I know that there's a lot of.
I think as quickly as possible. I would have liked to make a decision today. Let's aim for ACDT then. Okay. I think we might sort of nominally have more CL participation there. So
yeah, and we can at least ping the CLs and try to get them to, if they can't show up, articulate their reasoning async ahead of the call. Okay. Let's do that then. And then there's obviously the PR people can engage on async. Anything else on this before we move on? Yeah, to Perry's point, I think it would be good for all of the CL teams to either share their opinion before ACDT or on the call. And
I guess the question is if the CL teams are mostly going to look at it from an implementation perspective, or do we expect them to look at it from a process or philosophical perspective as well? Because I think that was the reason it was brought up in ACDE.
That's okay. Yeah, Barnabas?
Yeah, so I've tested the change on Kurtosis DevNet, and all the different CLs can adjust it as expected. So it's a config change. There's no technical question about it.
then I think I would be inclined to give people some more time to voice like their views on it at that level, and make the call next week on this CL call rather than ACDT, even if it's a bit farther out. And
Yeah, I mean, so it is like a one-line change, literally. It's just then this implies probably another dev net, more testing, like it just pushes out timelines.
Do we want to actually do it? Yeah.
Yeah, I mean, my take is we want to do something here at some point. I just don't think it's right now.
Okay. Ansgar?
Yeah, I mean, I would just also say for process reasons, this is a big change. Not technically, I understand this. Technically, it's pretty trivial, even though it would imply a new DevNet and everything, but it is conceptually like a very big change. And also, I mean, as was even brought up when describing it, it's not like something that was only said a couple of weeks ago. Like this specific value has been in the spec for like over a year, so people had a lot of time to look at it to potentially propose changes. I just think it's too late into the process to now discuss like a very meaningful change with basically not giving people a lot of time to form opinions, to not have this debate. I really think it's a meaningful enough topic that it would require a lot of debate, and I think just rushing to a decision, I think is just not appropriate given the kind of fork process.
Right. But I guess, yeah, to be clear, we will still be rushing to a decision. The decision would just be maintain the spec as is, right? So if there's anything that we would learn in the next week that we think could help shape the decision, I think it's worth trying to do that. If we don't think so, then yeah, I would also bias towards not making changes at this point. Sorry, Saba, what is not just blob parameter?
Basically, he wants to change the value in the BPO.
Yeah, BPO is an interesting concept, but we will be more and more running into BPO not just being a parameter only change. And
I mean, yeah, that is, I guess, an option is we could not have this launch with Fusaka, and then to the extent it becomes more urgent to address, we can overload the BPO to also have this.
Yeah, exactly.
They also assume that the CGC value does not go down, by the way. So once we introduce this, technically you're not going to go down in your CGC value. Unless you, nuke your DB, but.
Right. Okay, then I guess I would lean towards not making this change. And yeah, just because we're so late in the process, trying to minimize the amount of changes to the specs. We should still have the discussion and think through kind of the design principle implications further. But if we find that there's something so important that needs to be addressed, we can do that in one of the BPOs. But for Fusaka, we can omit this change. Does that make sense?
It makes sense to me. But I guess just clarifying, are we starting this today, or we're just stating it as a summary and then we'll take this to ACDT or C next week?
I'm fine not discussing it on ACDT if people here are okay with it, but.
Okay, so yeah, let's just say this is like the preference right now, and then we can finalize on next week's ACDC.
Well, on Monday we're gonna find out if we're gonna need a new DevNet anyway regarding the max transaction. So I think if we can make a decision about that, then on that call, I think we can also make a decision about this.
Yeah, like if we don't need a new DevNet, then I think that would lean us much more heavily towards not including this change. Yeah.
Okay.
Okay. Anything else on this one before we move on? Yes, we are discussing the transaction gas limit cap on Monday, Mario. Okay, and then the last Fusaka thing I wanted to discuss was just continuing the timeline discussion we had last time. So Alex had proposed a timeline, which would mean that around September 1st, we get the client releases for testnets, and then for testnets through September, October, and potentially mainnet early mid-November. And then, some concerns about forking during DevConnect. But I think any of the proposed schedules that get us to fork before or on DevConnect assume that we have the client testnet releases out around September 1st, which is a month from now. Do people think this is realistic? Are there things we should be doing to make sure we can get there? Yeah. Are things we should not be doing? Like, for example, if we do change this transaction limit cap, the client teams feel like it makes a difference between whether they can have a testnet release in 4 weeks or not. Yeah, Sean?
So for Lighthouse, we were talking about this yesterday. For us, yeah, the 4 weeks for the release is like aggressive, but we think doable. We're a little concerned about there's some adversarial testing that we're trying to start doing right now, and if that were to reveal some bad stuff, that might push back the timeline a little bit. But so maybe like an extra week or two padding would be good for the first release, but we still want to hit the DevConnect timeline. So yeah, that was our thought process.
Thanks. Anyone else? Okay, then if there's no other major comments, then I think, yeah, we should basically plan everything as though we're releasing the first testnet on September 1st. Obviously, if we find a major bug, we should always fix that, and that might delay things. Then in terms of the testnets, do people have preferences between forking Sepolia first, Hudi first, and whether or not we should fork Haleski?
Okay, need to do Haleski. The upside is it's just another sort of shot on goal, so to speak. The downside is it's just another attention sink.
Yeah, I think the only benefit of forking Holsky is that we do have enough public nodes, so we will collect some P2P data. But yeah, the downside is extra time.
There's a comment by Phil saying that we talked about doing some non-finality testing with the releases. Should we use Haleski for that?
Yeah, we can use Holsky for that. We also wanted to spin up a different network for non-finality. We're just waiting for a proper final spec freeze and all the other bugs to be sorted out before we spend the money on non-finality testing.
Because then, one schedule could be something like we release, on the week of September 1st. We fork Haleski on the week of, if we have if we have 2 weeks between every testnet and we fork all three, that brings us to October 15. And that means if we want to wait a month after the last testnet, we would be forking during DevConnect, which feels
feels not ideal. So if we do want to fork Haleshki, then we probably should do something where maybe we have like, I don't know, 1 week between the release and Haleshki, and then, you know, a week or two between Haleshki or between Sepolia and Hudi.
We could use
Yeah.
the same release for Holsky as well as Sepolia.
Yeah.
And one of the benefits of having non-finality testing on Holsky as well is that it shows people explicitly that we want to deprecate the network, and it'll avoid the scenario where my infra has worked well, so I forgot to migrate.
Right. So yeah, one option could be that, like, you know, week of September 1st, we put out the releases for Haleshki and Sepolia. Week of September 8th, Haleshki forks, because I assume we're controlling most, if not all, of the nodes on this. So we can clearly like update in time. And then week of the 15th, Sepolia forks. We put out another release after that, and then we fork Hudi on the week of October 29th. Assuming all of this goes well, it means we could fork on the week of September 29th, and this means if everything goes well, it means we can fork Mainnet on the week of October 27th or November 3rd, which are right before Dev Connect. Yeah, so I guess my schedule was basically what Barnabas posted, but then potentially shifted 1 week earlier on everything so that we can do Holesky 1 week after the client releases, given that we're going to do non-finality testing and that we control most of the nodes. And yeah, we don't have to like 100% finalize this today, but it would be good. It would be good to do so in the next week or two, especially if we are needing to set these blocks for September 1st. And I guess maybe a good way to move this forward is that if all the teams, like PanOps posted their preferences, but I think it might be good to hear from all the different teams by next call, and we can kind of finalize the happy path dates by next call based on the feedback from teams. Does that make sense to do on the CL call next week? Okay, I have a +1. But I think by this point, everyone knows kind of what the constraints are and, you know, how we can approach them. So let's try to get a final set of dates on next week's call. And obviously, if we find a bug and things things are problematic, we should always revisit that. But at least having our happy path set of sport blocks would be good. Okay, anything else on the rollout? If not, then we can use the rest of the call to discuss Glamsterdam. We discussed it a bunch in the past couple weeks. On last week's CL call, it seemed like there was strong support by the CL teams about ePBS. Still some open questions around potentially some other headliners. So we CFI'd ePBS, delayed execution, and Fossil, I believe, as candidate headliners. And then on the CL call, we didn't want to discuss block access list too much, but it is kind of the main thing that's come up on the EL side. So I guess, how did people feel about making block access lists kind of the EL headliner? Are there any objections to this at this point? It seems like the kind of least controversial and also somewhat smallest of the headliners. So yeah, I feel we may be able to lock this one in on the EL side today, and then finalize the discussion about ePBS shorter slot times and possible next week. Okay, so Besu guessed like BALs. Francis?
Hi, just to kind of like express Basis opinion on this a little bit or preference. For the EL side, we kind of like prefer delayed execution to BALs, and I think we like both. And the reason we prefer like delayed execution is that we think delayed execution can provide benefit to both the L1 scaling and L2 scaling, and also provide benefit to faster pre-confirmations. It moves the actual execution to the next blocks, which I think is a very good property to have. And it has, I think, from other analysis, has 80% of the benefits as opposed to of ePBS without the PTC, the new fork choice rules, and the other stuff. So yeah, that's just like our opinion. Just want to express it. But if everybody is like already aligned on that, I guess that's okay too.
Yeah, I guess one question I just posted in the chat as well, but from what I've heard of people supporting delayed execution, it seems like they would also want to do block access lists, but I'd be curious to hear from client teams like, yeah, like if we do delayed execution, do we think that this is somehow blocking for block access lists? Okay, Besu says yes.
I wouldn't simplify it down to a yes, Tim. It does change our math a little bit.
Yeah, and I guess this is kind of weird because delayed execution is mostly an EL thing, ePBS is mostly a CL thing, but they're kind of competing because they're both about their slots restructuring, and yeah, it seemed like all of the CL teams relatively strongly supported ePBS. So yeah, it's either we first make it an ePBS versus delayed execution decision, and that's gonna kind of go through another AllCoreDevs cycle, or we make the call around block access lists and commit to that, and then see whether or not we also do delayed execution. Yeah, Ansgar?
Yeah, I mean, I agree with you that the kind of decision process is a bit weird here because of the EL-TL interactions. I mean, I think in principle, we probably just all agree that if we do ePBS, then the EL headliner should be block level access lists. I do think that in a way, maybe, I don't know, it's weird to make that conditional decision, but like I do think, and I also think that the CL will choose ePBS, but I do think in a way we should not preempt, like it is weird to like just lock in BLs now, and then if the CL after all says, no, actually we want to push ePBS to H star and we're doing 6-second slots in Glamsterdam, then of course I do think we should revisit, and actually I would prefer delayed execution for us to do, or at least consider that over block level access lists. So I don't know. Like, I think the main decision for Glamsterdam is this ePBS versus delayed execution, and I think that is more a CL question. I mean, I do think at this point it is becoming pretty obvious that we are going to go with ePBS, but I still feel like in a way maybe we should just like only conditionally lock in block level access lists, saying like, okay, we assume it's going to be ePBS, so we say block level access list, but we revisit this if the CL surprises us, basically.
Yeah, I agree. So I kind of feel like I'm passing the buck here, but like I think we can probably CFI block access lists. Like it seems at least as there's at least as strong of a consensus on this than the three other ones we have CFI'd. We could make that like the 4 candidate headliners, and then we can make the call next week about ePBS versus delayed execution, and then assuming we do delayed execution, or sorry, assuming we do ePBS, then it would make sense to just also include block access lists. If we don't end up doing ePBS, then I think we'll need some more discussion. And it is a bit weird in terms of conditionals, but it's also not that crazy. So yeah, I would move to CFI block access list, make a call on ePBS, make a call on ePBS versus delayed execution, and then yeah, align on the EL side based on the result of that, but default to doing block access list if it's ePBS. Yeah, Ahmad.
Hey, so I wanted to express a different opinion from Francis on delayed execution being beneficial to L2s, because unless you're doing block building and doing the execution, and even if you're doing block building, you're executing as you're building. But if you are just grabbing batches of transactions from the mempool and sequencing them, whatever the highest priority fee or whatever, delayed execution will not actually provide you with that much benefit. That's my personal opinion, but maybe there is other considerations that I'm not seeing. But there is another consideration also about delayed execution versus ePBS here, which, as far as I'm concerned, ePBS delayed execution does not bring the same scaling benefits as ePBS when it comes to blobs, because and blobs are important for L2s. So this is another consideration that if we want to actually scale blobs higher, we should probably consider ePBS over delayed execution. But yeah, I'm also would like to hear feedback from others on this.
To answer your questions, for delayed execution does have tangible benefits for pre-confs, at least in L2. For example, for flash blocks that the OP stack is kind of like getting on right now, we have to reserve 500 milliseconds of time at the end of the slot to just do insertion of the block of the pre-conf blocks into the actual sequencer. And if we can do delayed execution, that 500 milliseconds can move to the next slot, which becomes a whole 2 seconds for the execution, and it makes the pre-confs much more smoother and truly like pre-confs in the time slots that we are building. So that's the first thing. The second thing about the ePBS has better benefits for the block scaling. Definitely yes. Our thinking currently, maybe it's not entirely accurate, is that based on what we've seen, seems like delayed execution can provide 80% of the benefit. And the other thing that into the consideration is that I kind of maybe it's just me, but I feel like the ePBS testing could be a very tricky thing to get to. I understand it's more stable, it's more mature at its current state right now, but I kind of fear with all the introduced changes, the testing can be very hard to get right and can delay the timelines. And finally, regarding the blob throughput, my current thought is that with peer death going out, that we can potentially theoretically get to 48 blobs, and the 80% of the benefits from delayed execution seems good enough for the foreseeable future for blob scaling. So yeah, that's my overall thinking.
Thanks. Okay, Mark, do you have that as well?
Yeah, I mean, I just wanted to make explicit that line of reasoning is their prerogative, but it's sort of like, we're advocating for delayed execution on L1 because it puts code that can best be reused on L2, not necessarily because it's the best option for L1. And that's obviously their prerogative and so on. But I mean, I think we also have a line of clients. Don't we have an implementation of I think we're committed to maintaining a version of Guess for L2s that has these kinds of features. And it doesn't necessarily mean that if we have a better option, not that he's saying that it is a better or worse option, but if we do have a better option for L1, that we can take that. And then, yeah, I mean, I think for me, one of the biggest reasons to do ePBS over delayed execution is the block payload separation, is the synergies with Fossil, and just like better, what is it? Like the types of low card, like proposer equivocation, low card crusader type attacks become better. Yeah, there's a lot of reasons to still do ePBS. And yeah, I guess that debate is probably going to happen next call, but yeah. So I guess my counter to that would be like, could we not do something like delayed execution for the layer 2 fork of Geth?
I mean, we've struggled to do more basic things on L2s and get them like adopted. So I'm personally quite bearish on the idea that L2s would adopt like a pretty big liner sized feature without L1 supporting it. Yeah, Francis, I don't know if you want to add more there.
The adopting that is definitely a concern, but it's I think as Mark mentioned, it's not absolutely not doable. Like, I guess my question is that my understanding for delayed execution is that it still has benefits for L1s as well. Just because like moving execution to the later block can free up the pre-com systems to be able to kind of truly like using the entire slot. So please correct me if I'm wrong there.
Yeah. So delayed execution would be helpful on L1 as well. Yes. Yeah.
Okay, then in that case, I think our kind of like previous argument is still valid. It's both good for L1 and L2, and yeah.
All right, thanks. So Felix and Tony.
Yeah, so I can just quickly go because you mentioned explicitly like implementation of this in Geth. So as far as I know, there's no active implementation of this change in Geth. Ultimately, the current strategy is on our side is that we do now, since the beginning of the year, care a lot more about basically trying to keep the upstream friendly for like any changes that are made in support of the downstream L2 forks of Geth. So I would actually love to discuss like the implications of implementing delayed execution for the use by L2s in Geth, but I also think it's maybe not entirely worth discussing it on this call. And also I think it's like there's no, like the timeline for it is also a bit different. Like we can definitely discuss it, but it's not like in the context of the Glamsterdam L1 fork.
Thanks. Tony?
Yeah, I think one thing that would be very helpful to have and to help us to guide the decision would be having some numbers on the final deadlines within the slot, because there was this free option problem that everyone heard of, and it would be super interesting to know what the actual difference between delayed execution and ePBS is finally, because initially, the delayed execution couldn't give you as much pipelining than ePBS because the PTC is just a smaller committee that you can put at the very end of the slot. This is essentially the trick, and it's a very nice one, but it also led to this free option problem. And then it's also worth discussing how much does this actually impact ePBS. Right now, I think it hasn't impacted the specs yet, but this is also like published end of last week or something. So it would be interesting to know like what it eventually does.
Okay. So I guess, yeah, this plus the comment around the free option, yeah, like the free option write-up. make me lean towards finalizing this discussion on next week's call. We should CFI block access this today. And again, I think if we move forward with ePBS next week, we can also make it clear we move forward with block access lists. But yes, industrial downstream of that decision. Does that make sense, people? And one thing, sorry, I forgot to mention as well, this came up in the chat, but we've collected on ETH Magicians feedback from the community on which headliners they would like, and Nixel posted the link as well, and ePBS, or sorry, not ePBS, block access lists came up like quite frequently in that thread too. So I think even beyond just the core devs group, it seems like there's strong support for block access lists. Yeah. So we'll move forward with CFI and block access lists. We'll make a final call on the headliners next week, at least on the CL side. If that headliners is ePBS, then we'll also have block access lists alongside it. Anything else people want to discuss about Glamsterdam before we wrap up? Okay, then we can we can call it a day. Again, the main three things is figuring out next steps on the transaction size limit on the testing call next week, and then the headliner discussion and timeline discussion, the Glamsterdam headliner discussion and Fusaka timeline discussion on the CL call next Thursday. Ansgar, do you want to add anything before we wrap up?
Yeah, just very quickly, I wanted to double check because I do remember that block lists had some variants. Now I think already at Interop we looked into those, right? And like I think there was this general feeling that the current variant of the EIP, which basically includes just the read locations and then the write locations and values, that is basically the best version of block access lists. But given that that was a bit of a design space and basically different options at some point were all thrown around, I just wanted to double check, like, are we at this point, now that we're CFIing it, already confident that like the version as is in the EP today, it seems to be my favorite version, but I just wanted to get a temperature check. Are we basically CFIing block access list and saying, oh, we're still gonna like iterate on like what exact version of it, or is this already kind of a vote of confidence for that specific flavor of it?
I think right now we are kind of early in the process because no one from the clients has a complete implementation except Geff. So I think Jared is, as we're talking, collecting some first numbers there. So we should have them very soon. And if we're talking about the size of the object, then the reads wouldn't matter that much. So I think 30% of the block level 30 kilobytes is from storage changes and only 10% from storage locations. So from the size perspective, it wouldn't matter that much. If clients say we don't need the read locations to do parallel I/O, then we can still exclude them. We have spec'd both versions. There are also tests for both versions. It should be a quite easy change to move from including the storage locations to excluding them.
Wait, just to be clear, are you saying that including the read locations bumps the size by 30%? Did I understand that correctly?
No, yeah, exactly 30%.
So
yeah.
I guess I would say like right now, and I plan to grab some benchmarks related to the read locations, but intuitively it just doesn't, I don't understand why they're needed, because it would seem like they would be important for being able to prefetch reads ahead of time. So like when you start the transaction execution and right now you're doing the transactions serially, if you had some pre-knowledge of read locations, you could fetch them ahead of time. But if we're executing transactions in parallel, that doesn't really leave time to do that. So right now I guess I just don't see what including them brings to the table. But I mean, we can certainly get numbers.
I mean, it does bring additional because you're not if you've got 8 CPUs and you're executing 8 transactions in parallel, you can do the reads for the transactions further down the pipeline already. But just like I say, it sort of depends on whether ePBS is the choice, because that gives more time for larger blocks. And yeah, I'm not sure delayed execution does. So the size of the block level access list would change propagation.
Okay, so I guess, like, yes, clearly there will be some exploration to do on this specific variant. Yeah. Anything else before we wrap up? Right. Well, yeah. Thanks, everyone. I'll post the summary later today, but again, 3 main things are transaction limit, Fusaka timelines, and CL headliners to sort out next week. Talk to you all soon.
Thank you.